All right, students, welcome. This video is for this Thursday, April the 2nd, 2020. Hope you guys are staying safe and finding something constructive to do with your time. I know you are, right? You're not driving your parents crazy. So anyway, here's just a little heads up, all right? Love you so much that I'm giving you a quiz over these items, these topics we've been discussing in the last few videos. How to solve quadratic functions by factoring, by quadratic formula, how to identify the characteristics of a quadratic graph, and of course we talked about the discriminant on the last video. All right, so what this is a little bit of a review day that we're going to be spending our time with to really help make sure you aren't getting the different items confused. And I'm going to add one more to it because you can handle it. Also, if you've been in my Algebra 1 class, we touched on the square root method, but we didn't really hit it with my Algebra 2 folks. So I'm going to kind of give you an overview of that because I feel like we're ready, okay? This is a different type of method, I'll say it that way, of solving a quadratic function. Notice this is written in what's called vertex form, although it's not completely set up that way yet. This can be solved primarily, the best way, I agree, is the square root method. And if you haven't seen this before, or even if you have, look at it again. Because we're going to go over a review on the different methods. You got square root method. We're going to do one where it's factoring. This one right here we haven't discussed. It's called completing the square. I'm not going to use that method because quadratic formula always works. And quadratic formula really is an idea that came out of completing the square. So where it says complete the square, we're going to use just two examples of the quadratic formula, okay? Just going to go ahead and get that disclaimer out there. So here's the first one, square root method. Pay attention. It's actually quite simple, but if you haven't seen it before, you need to look at an example. Here it is. You got parentheses x plus 3 squared plus 2 equals negative 10. That's my computer screen, so I'm going to move it down here where I can do the work with you. Here's the square root method. Well, just like any time you're trying to solve for a variable, you want to get it by itself right now. That's our goal. But you can't get it by itself because right now, x plus 3, it's in parentheses, it's being raised to power 2. You got to do first things first. So the first thing I'm doing is I'm moving this guy over, all right? Plus 2 is easy to move. So I'm going to subtract 2 on both sides. Boomity boom. We got negative 12, and I'll just bring down what I haven't really dealt with yet, and that's what we got, okay? First step, not so bad. That's the easiest thing to move over. I'm going to move it over. I want to get x by itself, but in order to do that, I have to deal with this pesky power 2. That's why it's called the square root method, because the only way to undo a power raising it to a power of 2 is to do the opposite of raising it to a power of 2, which is to take the square root. If you square root that thing, square root it to both sides, check this out. What that's going to do is it's going to undo raising it to a power of 2 and free this up and just make it x plus 3, right? And let's take a look here. That's being set equal to the square root of a negative 12. Now, I'm throwing a lot at you here. You need to pay close attention because no one has seen an example quite like this before. If you notice, at this juncture, we kind of have a problem because you technically cannot take the square root of a negative number. When we talked about the discriminant, we said, hey, anytime your discriminant's negative, you're always going to have two non-real solutions, or what they call imaginary solutions. All right? You can't really take the square root of a negative number and get real solutions. But there is an idea, a concept called imaginary numbers, and I'll even show you how to graph that when we get to it. Okay? So here is something new to digest. It's going to be kind of funny, but you need to understand there's nothing times itself that will equal a negative number ever. Because negative 3 times negative 3, for example, equals a positive 9. So the square root of 9 is never going to be negative. The square root of negative 9 would never be anything because anything times itself equals a positive. So this technically, you're not going to get real solutions. And whenever you're doing these kinds of problems and you come to a point where you're asked to take the square root of a negative number, you need to just simply rewrite it as a positive and put this little symbol here. That I stands for imagination. We're using what are called imaginary numbers. Mr. Morris, are you kidding me? Not only do I have to figure out what a real number is, but now we have something called imaginary numbers? Yes, but it's not that difficult. For right now, just know if there's a negative radicand, that means you're taking the square root of a negative number, you're going to end up with an imaginary answer. Okay? So, after you do that adjustment, it's really not so difficult, not anything you haven't seen in the past, because you still need to reduce this in what's called radical form. And we've done this in my Algebra 1 classes, probably more, but those of y'all in Algebra 2, I want you to look at this. I'm kind of throwing the kitchen sink at you, but pay attention. It's not that bad. So 12 is not a perfect square, as you see. You can't take the square root of 12 and get like 3 or 4 or 5. You know, it's going to be some decimal. It's going to be kind of nasty, right? But you can reduce it in what's called radical form. In other words, maybe 12 isn't a perfect square, but are any of its factors perfect squares? Like, let's think about it. 12, the factors of 12 are 1 and 12. Okay, that's not going to give me a perfect square. What about 2 and 6? 2 times 6 does give me 12, but 2 is not a perfect square, and neither is 6. Let's see if there's anything else. Ooh, you know what? 3 and 4. Square root of 3, square root of 4. 3 and 4 are also factors of 12. And guess what? One of those factors is the perfect square. Can you guess which one it is? That's right. 4 is. What is the square root of 4? 2. You're right, kids. So the square root of 4 is 2. So I can rewrite that as 2. The square root of 3 isn't able to be reduced. I just leave it under the radical. And so when I write out this answer reduced, see how I did the tree? I want you to do the same setup every time. You're going to take that 2, and I like to put it out to the left because that's usually how you see it. The square root of 3, you can't do anything really with it, so you just leave it there. And don't forget, there's an I. You can either put it out to the right, like that. That's acceptable. And let me just go ahead and bring down what I haven't finished with it. All right? You can either leave it like this. I've also seen people put the I out to the left. It really does not matter, okay? As long as there's an I there, you can have it on the right side or you can put it over there with the 2, okay? I've seen it on both. So, like, just think about that when you're taking the ACT test or something. They'll probably leave it like this, to be honest with you, okay? So here's what we did, just to recap. We said, okay, we had a negative radical. You need to change it to a positive, make it an I, okay? That's just first step you got to do. Then you took down the factors of 12 because 12 is not perfect square. You said, which factors have a perfect square? Only 3 and 4 because 4 is a perfect square and 4 times 3 equals 12. So you took the square root of 4, got 2. 3 just left underneath the radical. So that's where we are. Or you could write it this way. As long as there's an I, a 2, and a square root of 3, you're good. Okay, so I'm going to go with this one because that's how I wrote it initially. We're almost done. And it looks funny. It does look funny. But our final answer, you got to get x by itself. And right now, x isn't by itself. So the only way to do that is to subtract both sides by the 3. You see that? Subtract both sides by the 3. So that's going to leave you with x equals, you got negative 3, right? Negative 3 plus 2 times the square root of 3i. Negative 3 plus 2 times the square root of 3i. All right? So we are just about done.